This question is asked in gate 22 of electrical. This is from network subjects and from the resonance topic. The question is, the network shown below has a resonant frequency of 150 kHz and a bandwidth of 600 Hz. The Q factor of the network is dash. Okay, so we have seen in the theory, okay, bandwidth is given by resonant frequency divided by quality factors. So quality factor Q is equals to resonant frequency F naught divided by bandwidth. So here the resonant frequency is 150 kilohertz. So it is 150 into 10 raised to power 3 and the bandwidth is 600 hertz. Okay, so 150 and this is 4 and this is 1000 by 4. So that happens to be 250. So this answer is 250. This question is asked in gate 22 of electrical. This is from network subjects and from the transient topic. The question is, in the circuit shown below, the switch S is closed at T equal to 0. The magnitude of the steady state voltage in volts across 6 ohm resistor is dash. Okay, so here one important term that you should note is they're asking the informations at steady state. What is the meaning of steady state? Meaning of steady state is at T equals to infinite. So if they're asking the information for all value of time, then the questions will be a bit lengthy. But as far as this question is concerned, they're very particular about the information at t equals infinite. So it is very simple then. Then what we do is at t equals infinite, so here the capacitor behaves as what? Open circuits. So because if the inductors will be short circuit, capacitor will be open. In this case, you have only capacitor. This will be like open circuits. And if you observe the switch is getting closed at t equal to 0. So that means definitely at t equals infinity, switch is definitely closed because no more switching is happening. So at t equals infinite, capacitor behave open circuits. And as far as this question is concerned, the switch is in closed state. Switch is closed. So considering this, if I am drawing the circuits, how does the circuit will look like? So the circuit will be something like this. This is 6, this is 3, okay. So then you have the capacitor is open circuited, then you have 10 ohms, okay, and then you have a battery of 10 volts with this polarity, and then the switch is closed. So I'm putting two dots, and you have the 2 ohm resistor now. And what they're asking to find the magnitude of steady state voltage across 6 ohm resistor. So magnitude means whichever the polarity we take, it doesn't matter. So basically this is minus, this is plus, let's say. So this is Vx. So Vx we are supposed to find. So for our convenience, like we can redraw the circuits just by tilting it this way, right? So if I'm doing it, so how does the circuit look like? So we have for this particular branch, we have a 2 ohm resistor, and then we have the switch, and then we have the 10 volt source with this polarity, and then we have this 10 ohm resistor, and then we have the open circuit for the capacitor, and then we have 2 more resistor, 3 ohm and 6 ohm, which are in parallel. So this is 3 and this is 6. So this voltage Vx we have to find. So polarity is not given, but anyway magnitude is asked, so whichever the polarity you can take, it doesn't matter. Okay, so it's very simple. So by voltage division rule you can easily find it out, because this segment is open circuit, so no current will flow into this. So there is no question of any voltage drop or current flow in these segments. So this 10 volt source, you have only one source, and this 10 volt source will be divided among this 2 ohm resistor and the parallel combination of 6 and 3. So we need this Vx, right? So Vx by voltage division rule can be written as 6 parallel with 3, right? Because this is, you have to take a single resistor. 6 parallel with 3 divided by 2 plus 6 parallel with 3 into the supply voltage is 10. 6 parallel with 3 is 2, so 2 into 10, and this is 2 plus 2 into 10. So this is happening to be 100 into 2 is 200. 200 by this is happening to be 4, right? Am I correct? Is it 200? 2 into no, it is only one time I have to take. Why I am taking 2 times? Here it is 6 parallel with 3 is 2 into 10 divided by 2 plus 2. Yeah, So if it is the case, then this happens to be 20 by 4, and 20 by 4 is 5 volts. So whichever the polarity, even if I have taken this is minus, this is plus, but as far as the magnitude is concerned, both of the cases you will be getting the answer as 5 volts. So very simple. So by observing the questions we got, it is asking the information at t equals infinite. So at t equals infinite, we have drawn the circuit. This is looking like this. And then by simple voltage division rule, we are getting the answer to be 5 volts. So 5 volt is the right answer for this question. This question is asked in gate 22 of electrical. This is from network subjects and from fundamental topic. The question is, in the circuit shown below, the magnitude of voltage V1 in volts across the 8 kilo ohm resistor is dash. Okay. So we need to find this V1, which is the drop across this 8 kilo ohm resistor. Okay. So it's a very simple problem. So it is wise to go by the inspection method in this case. So what we'll be doing is, so let me write a KVL equation in this particular mesh. If I do that, what I'll be getting? 75 minus 2i minus 0.5 V1 equals to 0, right? 75 minus 2i minus 0.5 V1 equals to 0. What I need V1, right? So in this equations, to get V1, so I need to replace, or I need to express this I in terms of V1. So if you observe this particular segments, I can say V1 is equals to 8I, right? Because if this is the current I, so this I is flowing through these segments. So V1 is equals to 8 into I. So you need I in terms of B, right? So I is equals to V1 by 8. So you can substitute it here. So I can say 2I, that is 2 V1 by 8. So in this I substituted V1 by 8 plus 0.5 V1 means it is V1 by 2 is equals to 75. So this is basically how much? V1 by 4 plus V1 by 2 is equals to 75. 0.25 plus 0.5, 0.75. 0.75 V1 is equals to 75. V1, if you check, so this is 75 divided by 0.75. So naturally this is 100. Isn't it? So 100. So straight away, the answer of V1, which is the drop across the 8 kilo ohm resistor, is 100 volts. So one simple KVL equation is enough to get the answer. Answer is 100 volts. This question is asked in gate 22 of electrical. This is from network subjects and from three-phase circuit. The question is, two balanced three-phase loads as shown in the figure are connected to 100 volts three-phase 50 Hz main supply. Given Z1 equals to 18 plus J24 ohms, Z2 is 6 plus J8 ohms, the ammeter reading in amperes is dash. Okay. So here we have the ammeter, we need to find its reading. So you know very well, ammeter always reads the magnitude of the corresponding phasor. So ammeter means it will read currents. So I need to find basically this particular currents. Okay. So this is the line current, which is the, the R segment current. So naturally you might be getting the idea. So by observing the circuits, so what we will be doing is, so we'll be converting the inner star into its equivalent delta. So this is this Z2, 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 this is what? A star. We'll be converting into its delta model, so that we can have access to find the Z equivalent basically. And you have already learned, so like if we have in the star all the elements are identical, so in the corresponding delta, so their value will be multiplied by 3. So basically I mean to say this is Z2, Z2, Z2. If I find this corresponding delta, delta, delta in 3 arms, so their value will be 3Z2, 3Z2, 3Z2. So let me do one thing for this particular segment. So let me draw its corresponding equivalent model, how it will be looking like. So this is your the R line. So this is what is my ammeter. Okay. So this is the outer delta I'm keeping as it is. This is Z1. Right. So this is Z1. This is Z1. This is Z1. And if you convert this inner star into delta, so where this delta will come, one arm will come here, which is in parallel with Z2, other will be here, and similarly here as well. So basically, like if I ask you to do this thing, so this is your R segments, this is your Y, and this is your B. So if you convert this inner star into delta, so you have a impedance will be here. You have one impedance here, and you have one impedance here. And what are their values? As I'm keep on saying, because the Z2, 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 these are our same values. So in the corresponding delta, so it will be 3Z2, 3Z2, and this is also 3Z2. Okay, so now the next task is to replace this Z1 parallel 3Z2 this by a single impedances. So if I do that, so what I'll be getting is, so the corresponding circuit will look like this. This is what is my ammeter. Okay, so let me first draw the corresponding arms. This is Z equivalents. This is also Z equivalents. And this is also Z equivalent. What is Z equivalent? Z equivalent is the parallel combination of Z1 with 3Z2. So this is your R, this is your Y, this is your B. Okay, na? So Z equivalent is Z1 in parallel with 3Z2. So this is 3Z1 Z2 divided by Z1 plus 3Z2. If you simplify this, 3 into what is the Z1 value given? Z1 is given 18 plus J24. So 18 plus J24 multiplied by what is the value of Z2? 6 plus J8. So this is 6 plus J8 whole divided by Z1, which is 18 plus J24 plus 3Z2. So if you multiply 3 with this, so this happens to be 18 plus how much? J24. So in fact, if you see, like these are, you can think of like this equal cases. So this is equivalent to 18 plus J24, and if you multiply 3 here, so this is again 18 plus J24 divided by 18 plus J24 plus 18 plus J24. This is like two same impedance here parallel, Z1 into Z2 divided Z1 plus Z2. So both are same, so it will be Z by 2. That is 18 plus J24 divided by 2. So this happens to be 9 plus J12. So Z equivalent value is this much. Okay, so which current we need? We need this current. So do you know this voltage? Yes. How much is given? This voltage is given 100 root 3, right? So if you see, so yeah, so this is given 100 root 3. Okay, so so basically I need this current, right? So this is the current which is going from the R line. So this is nothing but the line currents. And if you observe, this is nothing but a delta load. And in a delta load, how does the line currents and phase currents are related? In a delta load, so you know very well, you have already studied this in the measurements or in power system or networks. In a delta connected load, the line current is given by IL is equals to root 3 time I phase. What is the phase current? Phase current is the current in this branch. Okay. So why I am thinking this way? Because finding the I phase will be straightforward in this case, because the voltage, if it is 100 root 3, this voltage is getting applied to this particular arm, right? So I can easily get what is the phase current. If I get phase current, I need this line current. I can use this particular formula. So the line current is root 3 into I phase. So this is root 3 into I phase. What is I phase? I phase is this current. Okay. So this is 100 root 3 is the voltage, and the impedance is Z equivalent, which is how much we got? We got this is 9 plus J12. So this is root 3 into 100 root 3 is 300, right? Root 3 root 3 is 3. 3 into 100 is 300. Divided by square root of 9 square is 81 plus 12 square is 144. So take a calci and simplify this. If you find it out, so this is happening to be 20 amperes. Okay, 20 amperes. Now why I have taken here magnitudes? So why I have taken a magnitude? Because ammeter always reads the magnitude, right? Not the phase. So while computing the ammeter reading, voltmeter reading, by default you take the magnitude. That's why for this particular complex number, okay, which is Z, you obtain the magnitudes. So the answer is 20 ampere for this. So this is again a simple questions. So from the given complicated network, so first what we did is we have obtained this particular model, okay, using the star to delta conversions. Then I have again drawn a simplified version of this. Then I figure it out, okay, this is what the current we need. Then by observing the structures in the delta connected load, it is easy to find the phase currents because the voltages are directly getting applied to the individual arms or in the phase. I can get the phase current. What is phase current? Phase voltage by the impedances. Then once I got the phase currents, I can correlate the line current using the formula I equal to root 3 I phase. So this is the formula, and for I phase, this is what is the V phase by Z equivalent. So by simplifying this, the answer is 20 amperes. This question is asked in gate 22 of electrical. This is from network subjects and related to the AC power topic, you may say. The question is the voltage at the input of an AC-DC rectifier is given by Vt equals to 230 root 2 sin omega t, where omega is 2 pi into 50 radian per second. The input current drawn by the rectifier is given by this expression. The input power factor is dash in the lagging form. Okay. So this is a standard model question which is already asked in gate 2011 also. Okay. So what we do in this kind of cases is we have a well-known formula from the power triangle, like P is equals to mod S cos phi, where P is the average power, mod S is nothing but the apparent power. So you need the power factor which is cos pi. So the power factor which is cos pi is given by P by mod S. So based on this data of voltage and currents, we can get the information of P as well as mod S, and then we can substitute in this to get the corresponding answer. Now the question comes, so what is this P and what is this S? So S is given by product of V RMS magnitude into I RMS magnitudes. So you know, like if I ask you what is V RMS, so this is what is the Vt, this is in the time domain form, and this is this amplitude in the peak form. So if I ask you what is V RMS magnitude, so this is given by 230 root 2 divided by root 2, because if you know the peak amplitude in a sinusoidal case, to get its RMS you have to divide root 2. So magnitude of V RMS root 2 cancel. So this happens to be 230. So in place of V RMS, I am writing here 230 into IRMS. So IRMS, so whenever we have a expressions of voltage or current which is, you know, linear combination of different frequency sinusoids, in that case the corresponding RMS value magnitude is given by, okay, the individual RMS magnitude square. So this peak amplitude is 10, so its RMS is 10 by root 2, its square, plus this is 4, so this is 4 by root 2 square, plus this is 3 by root 2 square. So this happens to be 230 and this happens to be how much? This is 62.5 you will get if you solve this. Okay, so 230 into square root of 62.5. If you use a calci, you will get this answer is 1818.30. So this is what is your mod S. So mod S is equals to 1818.3. This much of volt ampere. The dimension of S, the apparent power, is nothing but volt amperes. But how do you get P? So P is given by the standard formula, magnitude of V RMS into I RMS into cos of phi Z. In this case, if you see, the voltage having a single frequency, but the current having three different frequency, right? If you see, current having three different frequency like omega, 3 omega and 5 omega. But the voltage having only one frequency, that is omega. So while computing the average power, so the corresponding frequency term will contribute. In other words, because the current having only one frequency component, so while computing the average power, so this component and this component will come into pictures. So this component and this components are irrelevant. In other words, if the voltage would have the term of 3 omega and 5 omega, again they would have contributed. But because in this case current having a single frequency, that is omega, so the corresponding frequency of current will come into pictures. So while substituting this formula, so magnitude of VRMS, that is 230 root 2 divided by root 2. And IRMS, when I say IRMS, not the total IRMS. Don't think that this is what is the IRMS we have to substitute. No, the corresponding frequency component is 10 here. So its IRMS I am substituting here. This is 10 by root 2 into cos of, what is phi Z? So phi Z is given by theta B minus theta I. So the voltage angle is 0 if I take sine as the reference, 0 degree minus The current angle is minus pi by 3, which is minus of 60 degree. So if you simplify this, so this is how much? 230 into 10 is 2300 root 2 divided by 2, and this is cos of 60 degree. So what is cos 60 degree? Cos 60 degree is half, I think, right? So cos 60 degree is half. So this is happening to be 2300 root 2 divided by 4, and if you simplify this, this answer happens to be 813.17. This is watts, right? So you have the mod S, you have the P, you can substitute in this formula. So S I have already written, so P value is 813.17. So if you use the calculation and if you find it out, so this is happening to be 0.4472. So the power factor of the device, the rectifier which is given is 0.4472. This is what is the answer. So, this is again a standard repeated model question. It has been asked in the past, as I said. Again, the same thing they have repeated. Okay. So the answer is 0.4472. This question is asked in GATE 2022 of electrical. This is from network subjects or power system, you may say, based on the three-phase circuit. The question is, in the circuit shown below, a three-phase star-connected unbalanced load is connected to a balanced three-phase supply of 100 root 3 with phase sequence ABC. The star-connected load has ZA equals 10 ohms, ZB is 20 at an angle 60 ohms. The value of ZC in ohm for which the voltage difference across node N and N dash is 0 is. These are the options we have, right? So here some important keywords to be noticed is the load is unbalanced and the source is balanced. It's a balanced three-phase supply. The sequence is ABC or positive sequence, and it is said the voltage difference across node N and N dash is 0. Okay, so these are the key points that somebody should notice to solve this problem. So since the supply is balanced, what is the meaning of this balance? What can be said? So because the supply is balanced, I can tell the value of Vn is basically 0. Okay, and as far as the question is concerned, the voltage difference across node N and N dash is 0. What is the meaning of it? So Vn minus Vn dash, this value should be 0. Voltage difference across node N and dash 0 means what? Vn minus Vn dash is 0. So because already we know Vn is 0, so if I substitute here, so it means your Vn dash is also definitely 0. So, okay, so it's an unbalanced load, but the way the question is framed, we expect, even though it's an unbalanced node, the Vn dash difference should be 0. So indirectly they are saying that find the value of ZC in such a way that this node voltage N dash, Vn dash is basically 0. Okay. So, based on the questions, we came to the conclusion that they want to make Vn dash equal to 0. Okay, now it is very simple problem. See, let me name this current is IAA. Let me name this current is IBB, and let me make this current is ICC. Okay, so now if I write the KCL equations, okay, if I write the KCL equations either at N or N dash, no problem. So what do you get? So you get, if I'm writing the KCL at node N, so all currents are outgoing. That is, you want IAA plus IBB plus ICC. So this should be 0. Some of the outgoing currents, outgoing, this should be 0. Or if you write at N dash, some of the incoming currents are 0. That is also okay, no problem. So what is IAA? So IAA is basically EA divided by ZA. What is IBB? This is EB divided by ZB, and ICC is basically EC divided by ZC. This equals to 0. Okay. So now we have to substitute the values of this which are being given, and we can accordingly proceed. So what is EA? So if you see, it is 100 root 3. Okay, this is what is being given, and the sequence is ABC. So let's assume that this EA is 100 root 3 at an angle of 0. So if this is 100 root 3 at an angle of 0, so if I ask you what is EB, so 100 root 3 at an angle of minus 120 degrees, right? And what is EC? So this will be 100 root 3 at an angle of minus 240, or it is equivalent to plus 120 degree. Both meanings are same. So because the sequence is ABC or positive sequence, so by default we take A as the reference whose phase is 0, and then rest of the things are 120, 120 shifted. So based on that data. So now we have this EA, EB, EC. We have the ZA, ZB given in the questions. The only unknown factor ZC you have to find by solving this equation. So some complex mathematics is needed now. So EA is 100 root 3 at an angle of 0 divided by ZA is given 10 ohm, right? So ZA is 10. EB is 100 root 3 at an angle of minus of 120 divided by the impedance is 20 at an angle of 60 degrees, plus EC is 100 root 3 at an angle of plus 120 degrees divided by ZC. This equals to 0. So now we have to simplify this. What is the first term? You will get 100 root 3 by 10. So this is basically 10 root 3. 10 root 3 at an angle 0 is equivalent to 10 root 3. And what is 100 root 3 by 20? This is 5 root 3 at an angle of minus of 180 degrees. Plus this is, or you can take it to other side. So if you take it to other side, this is minus 100 root 3 at an angle of 120 degrees divided by ZC. Okay, this is what the situation is. So this is 10 root 3, this is minus 5 root 3 because, okay, so if the phase angle is 1 plus or minus 180 degree, so then that is equivalent to what? You can take it minus sign. I mean to say R at an angle of plus or minus 180 degrees is equivalent to minus R. Like R at an angle of 0 degree is plus R at an angle of plus or minus 180 degrees minus R, right? So I hope you have this basic. So this is equivalent to, okay, this is equivalent to minus of 100 root 3 at an angle of plus 120 degree divided by ZC. So this implies your ZC is basically minus of 100 root 3 at an angle of 120 degree divided by 10 root 3 minus 5 root 3 is basically 5 root 3. So this implies ZC is equals to minus of, okay, root 3 cancel. This is, okay, what? 20, 100 by 5 is 20 at an angle of 120 degrees. So you have this negative sign outside. If you want to take it in, so ZC is equals to 20, okay, 120 degrees plus or minus 180 degrees. So this implies your ZC is equals to 20 at an angle of, if I take the negative sign, 120 minus 180 is minus 60 degrees. I am not going with positive sign because it will exceed that range of 180. So you will get 120 plus 180 is 300. So we don't want to exceed plus or minus 180 degree, which is the standard conventions. And so this is what is the value of ZC we are getting, which is 20 at an angle of minus 60 degree, which is given in option what? C, 20 at an angle of minus 60 degree. Okay. So if you have patience to read the questions, in the question itself, the solution is indirectly given. The only thing that should strike your mind is, so even though the load segment is unbalanced, but still this node voltage is 0, Vn dash is 0. So it's very simple then. Then simply by writing a KCL, okay, we got these equations, and then by substituting the value and, you know, by solving this maths, we are getting the answer, which is 20 at an angle of minus 60, which is in option C. So C is the right answer for this question. This is of course not a tough question, but yes, you need 2-3 minutes of time because of the calculation involved. This question is asked in GATE 2022 of electrical. This is from network subjects and related to the quality factor concept. The question is, an inductor having a Q factor of 60 is connected in series with a capacitor having a Q factor of 240. The overall Q factor of this circuit is dash. Okay. So this question is based on a standard formula. If we have one practical inductors and if it is in series with one practical capacitors, then the overall Q factor QT is given by QL into QC divided by QL plus QC, where QL is the Q factor of practical inductors and QC is the Q factor of the practical capacitors. So naturally, right, because if it is ideal case, the Q factor will be infinite, right? Because if it is not infinite, that means it is having some resistive component. That means we are speaking regarding practical inductors and practical capacitors. So there is a proof in the theory, okay? So let us use the formula and substitute the value to get the answer. So QL is given 60 and QC is given 240. So 60 into 240 divided by 60 plus 240. So this is 24 into 6 into 100 divided by 300. So this happens to be 48. So the quality factor of the overall circuit is 48. So 48 is the right answer for this question.